The Sporland division of Parker Hannifin proudly sponsors the Advanced Refrigeration Podcast. There are a lot of questions surrounding the transition to A2L refrigerants and a lot of talking heads disseminating nebulous answers. But when your technician is face-to-face with the first A2L transition project, where do you turn for real-world answers about this specific job? Parker Sporland's Virtual Engineer is an innovative online design tool to size and select the correct components for climate control and refrigeration applications. Get your A2L system flow and component selection answers in 3 simple steps. Enter your application details, size, and select products, then download your project files. It's that easy. Try it at absolutely no cost. Visit sporlin.com and navigate to the Resource Center. Parker Sporland, leading the charge.
Jacob's pants have always been like tighter. And so I met him probably like 8 years ago when I went to Oklahoma, because he worked for a thing up in Oklahoma and he was the service manager. And I would just relentlessly just make fun of him for having so tight pants. I was like, I don't know how you have 3 kids. I don't know how that's possible. Your count must be really low from all that tightness. I was like, I don't understand. So later, like I think 4 years later, he started wearing looser pants, but they're still basically, I don't know how anything circulates. And he had another kid.
I like it more when you make fun of Greg. It's way more funny.
Oh, Jesus. All right. Good afternoon, everybody. Welcome to Advanced Refrigeration Podcast. You're here with your hosts, Brett Wetzel and Kevin Compass. So you're all fiery. What have you been? It's been hot and humid. Like,
it's been a fucking shit week.
Man, I was in Louisiana last week. I'm in Houston today, and I'm not liking it. No, I don't like it.
I was in the Houston to the north. And Ohio was like brutally disgusting Monday and Tuesday. It was like 97. And when I left the house in the morning, it was 78 degrees and the dew point was 77. It was disgusting. And I was on a metal roof with solar panels, which is my new hell. I hate solar panels. Fuck everybody that puts solar panels in. I hate them. Those people are the worst.
So what I don't like is the metal roofs that like you can't walk straight. No.
Yeah,
you can't walk straight because every single stride, like your ankle wants to twist on every
10 inches, like too small for you to do it. It's like 10. It's awful.
So what I found is if you walk diagonally, like you can get more stride, and then you don't end up actually wanting to
try that with solar panels.
And that was what I was about to say. Is you put in the solar panels in there, you're like, fuck, I can't even do that anymore.
It's the biggest asshole in the world put these solar panels into, because like they couldn't have oriented them any worse for you to walk on this roof. And it was like a maze. Like usually like at the Targets, they leave you like a path to get to the rooftop units. This is like you're just walking around all these solar panels and trying to die.
The other thing, too, like I said, the metal roofs are the worst because you already can't. I remember working at those stores all the time when I was out east, and your ankles by the end of the day feel like they're going to fucking fall off.
Oh, yeah, dude. I've been doing that for 2 weeks. So it's like running around those roofs, and it's like back and forth. But then you throw solar panels up there, and they're just, not to mention the silver roof is like tanning under your arms. Now the solar panels are getting you too.
Maybe that's what the hindrance was with RNB.
What?
You'll figure it out later. RNB. Take the initials.
Yeah, I don't know. It was not a good week. I was exhausted. And then this week the rest of the week I've been doing a PM at my fancy Walgreens.
Yeah, how's that going?
Boring.
What do you mean boring? I thought you found stuff.
No, I just got a glycol bath and
how'd that happen?
I was cleaning blowdowns on strainers and I heard a tink. And I'm like, what was that? I went to go shut the 3/4 ball valve and it wouldn't shut. And there's this glycol blowing out of the strainer.
Not good.
Yeah, it was a rock.
Wait, what?
It was a
rock inside the glycol line?
Yeah, who knows? There's fucking 600 feet of 600 foot or 300 foot deep wells. Who knows?
That's yeah, but you found it in the glycol, not the open loop.
It's all closed loop.
So how did rock get in there?
I don't know. How does stuff get in stuff all the time? How do rocks get in refrigeration lines?
I've never seen a rock in a refrigeration line.
Oh, I have plenty of times.
Screws, yes. Tons of screws.
Seen rocks, especially when there's like people getting mad at people.
Then they're assholes because that shouldn't happen.
When the sprinkler fitter has hard numbers and his hard numbers are way off. Then they drill through your coil and then there's a job site fight.
And then they draw penises all over your equipment.
Yeah, that's the pipe fitters too.
Bastards. Yeah, so I've been training in Houston this week. So I don't know. I saw my second parallel rack manufacturer to be left out, but because we're going to talk about some of the things that didn't make any sense that we're just going to talk through. I'm going to bring up an example, basically two examples of a parallel rack to explain what a parallel rack is. And then I'm going to bring up another PNID, and then we're going to kind of walk through it a little bit and see what's actually going on with it. And then, I don't know, I guess we'll just shoot the shit like we do every single other week about it. How does it sound?
Sure.
Okay. Does that make sense what I said before now?
Sure, it does.
No, I was talking about the text. Entire screen. Nope. Vinda. There we go. Share. There we go. Can you see that?
Yep.
Cool. I'm going off one screen, but today I have my mouse. All right. Parallel compression. Just like we have a secondary, some of the different end users out there, they'll have like a secondary rack. So you'll have a low temp rack, a medium temp rack, and then you'll have a high medium temp rack that does like subcoolers. And it also does like meat preps and produce preps and really high temperature, because it's wasted energy if you're pulling down and utilizing an EPR on a medium temp system. If you could utilize that for if you had a higher suction group, right? So essentially, it's a satellite compressor, if you will. So if you look at this diagram here, you have your high pressure valve going into the flash tank. And then down a ways, you have your BGV, but it's all the way down past this compressor. Sometimes they utilize a three-way valve to drive the refrigerant right to the compressor. Usually they actually put it through a heat exchanger because, like we talked about before, sometimes with the BGV, you'll have a little bit of liquid quality that ends up lowering your superheat or whatever, and they'll have a heat exchanger afterwards. But essentially, so let's just say this suction down here on your low temp would be somewhere in the midst of 200 pounds. Your medium temp would be 4 to 420. And then whatever your flash tank is running basically would be your intermediate temperature, your IT compressor, or usually I get referred to as an IT compressor. What have you heard it as other than parallel compressor?
Parallel compressor.
All right, never mind then. That compressor will be on a VFD. Typically what is usually done is they're taking the mass flow of what's actually coming through this line here. And then once you have the mass flow, you can figure out based off of your compressor horsepower here, how much of that mass flow would have to go to that compressor to keep that compressor running. So whether it be 56 or 65% of the BGV opening, you could essentially disable the BGV and then enable your IT compressor and essentially let your IT compressor run the flash tank. So if your flash tank's at 520, then you go in 520 on your suction here, and then going up to whatever your head pressure happens to be, 11, 12, or 1300, whatever. So essentially you have less of a compression ratio, because here you have 420 here up to, it's not much, but still you're saving a little bit of energy, and then it takes a little bit of load off of your actual medium temp compressors as well. So in a nutshell, that's what parallel compression is. The only thing that kind of sucks about this is different things have to be done in order for other accessories. The rack I was working on today had a lower pressure oil system. So instead of just having a oil separator that just went straight to the compressors, it had an oil separator that went to a reservoir. But typically the reservoir is then vented off into the flash tank. Here's the problem. If the flash tank is at 520 pounds and the IT compressor is at 520 pounds, that means that the reservoir is going to be at 500.
Worky.
520 pounds. And then, like Kevin said, no, basically you can't go from 520 to 520. It's like trying to do trying to do liquid injection on a parallel compressor off of the flash tank. No worky.
Oh God.
Right? Yeah, you remember that conversation?
Yeah, this has happened multiple times to me. Also, by the way, with this parallel compression in the oil system, and it's always an afterthought, and then it becomes a fucking nightmare.
So, like, I was talking with New Andre about it, and basically we were talking about like different means that you could do where it wouldn't take so much piping, right? You could put a differential check valve on the oil res. I have a 75-pound check valve. You could do like a bipolar valve, right?
I don't like the bipolar valve. I like the check valve, or I'm mechanical for this application.
Or we could do the LMP way, where you just put a oil regulator.
Yeah, but that wastes so much energy. It's just constantly bleeding pressure, and the LMP way makes the
no. All I meant is basically just raise the pressure where it raises it up a ways. You know what I mean? So if, let's just say the flash tank's at 520, we'd have to have, I'd like to see it around 100-pound differential, right, for the heat of summer, and then basically just regulate it up, because it's going to be regulating off the flash tank anyway. But at least if you have that, raising at a higher pressure, then it's not going to let so much gas out into the flash tank. You know what I mean?
Yeah, I don't like that way, just for the fact that when the rack shuts down, it makes the rack go.
Yeah, that's why we were thinking maybe a whatchamacallit.
A spring-loaded check valve works great, or a high-pressure oil system. If you're going to use IT compressors, a high-pressure oil system works much better.
Oh, I agree with that. I don't know if I can zoom this in. See if I can zoom it in a little bit better so you can see it a little bit better. Because this is another way that they do essentially parallel compression. So these are your LT compressors, here's your MT compressors, and then here's your ITs. So I'm just going to zoom in a little bit here. So
the thing with ITs is they're only efficient. It's only efficient to use the IT compressors at certain OA temps and loads. So
Yeah.
once your OAT temp is down too low, that IT compressor is not going to run. And this is where it becomes a problem, because they end up logging oil. They end up getting abandoned or having issues, or they go to start and they're full of liquid and they blow a head gasket and fog out the whole mechanical room. A lot of times IT compressors are more hassle than they're worth. But on a large system, they're worth it.
You know what? I'm just noticing something looking at this system right here. And this is the first time I'm noticing it now. So what do you notice about the oil system? So you have a high pressure separator. Jesus, that's loud. High pressure separator, and then it gets vented to the reservoir. But look where the reservoir goes. To the receiver. Okay.
It's not going to work.
It will for the low temp. It will for the medium temp, but it won't for the freaking IT. I'm just noticing this now.
Yeah, no, it's not going to work for the IT.
I wonder if they know about this.
Classic engineering.
Such a dick. But you see what I'm saying? Like the medium temp compressors, because whatever the flash tank is, right? Because, all right. So anyway, I'm getting distracted now. Let's talk about the IT compressor. So if you see here, coming off the high pressure valve, flash gas and liquid gets driven into the flash tanks, right? And then off the top here, blah, 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 off the top.
Jesus, They got enough liquid cores in this rack? God, they just really want to fucking make people angry.
This is a big fucking rack.
Can we go with 2, like 4 shells and not like 3?
Okay, so each one of these is 2 1/8, sir. 2 1/8, 2 1/8, 2 1/8. So this is a big bastard.
Should go with the Hill Phoenix way, no liquid cores.
You're a bastard. Shut up. So anyway, so you have the flash gas coming up the top, and then coming out through this heat exchangers, which is awesome because usually you'll have a little bit of lower superheat getting flashy off there. And so you're basically changing out some energy with the drop leg, which is great because the liquid coming out will be a little bit more efficient. And then going through the bypass gas valve like we typically do into the medium temp suction. So in this way, it drops right into the accumulator. Here we have the IT compressors. So what's supposed to happen when these things go into IT mode is essentially you have your BGVs shut down, and now the flow of refrigerant will be forced over to the parallel compressors. And so then they handle whatever that flash tank pressure is, and wham, bam, thank you, ma'am. Then you save a little bit of energy. But like I said, now that I'm looking at the oil system, that's bad.
This happens all the time.
Yeah, but I didn't notice it before because I wasn't following. Like you said, it's an afterthought. I wasn't really thinking about the no worky effect. But now I'm thinking about the no worky effect.
I see more IT compressors disabled and removed off racks than I do ones that are running.
Really?
Yeah, because they end up using them. They end up piping them into the main header and either using them for more capacity on that. Because a lot of times they cause more problems than they solve.
I could see that with this oil system here and the other oil system that I saw. And this is two different manufacturers.
Yeah, it's that oil system, and then it's the fact that you have compressors that are sitting off for 5-6 months a year, maybe even more.
Unless the rack's used as, or if they're bump up the head pressure for a lot of, like we were talking to, remember Damian Reed? He's talking about his chiller where basically they're using TC all the time, trying to produce as much heat. Like there, it would be amazing.
Yeah, but they need the load, so not really. They need the flash gas load to make the hot water. They need the heated compression.
Oh, I see what you're saying.
So they need the mass flow and heated compression. So really, I don't know. Parallel compression makes sense in large industrial applications, like a rack like this. Yes, it makes sense. This is a huge rack. This makes complete sense to have parallel compression. But here's where the problem comes in: is I see a fixed speed compressor and a VFD compressor. It's going to be shit.
If that compressor takes a poopy.
Yeah, but like your parallel compression is going to be awful if that compressor takes a shit. And here's the obstacle of parallel compression. You have to beat that iPro controller or that BGV controller in making this thing great. You know what? Now that I'm thinking about this, why not just mirror the signal from the BGV and make that drive the compressor?
What, just do 0 to 10 signal?
Let the iPro mirror the opening for the compressor drive.
That would be something that would have to be played with. Because I'm sure
it would have to be played with, but like the reaction time would have to be played with. But that would be interesting to see. You'd have to rescale it because obviously you can't take the compressor down to 0. You would have to make some plays with it, but instead of taking the BGV signal and mirroring it somehow to the compressor signal and let the iPro drive the compressor.
Yeah. You still have a suction group. So that's the thing about these. You're essentially gonna have 3 suction groups on this, right?
Correct.
You're gonna have the plus 18, the minus whatever, minus 20, let's just say, and like the plus 35, let's just say. Yeah, because we were talking about this, trying to figure it out, and I was talking to New Andre about it and trying to see what he said, and we were throwing some things back and forth. I'm waiting for the actual paperwork because I need the refrigeration schedule. And don't laugh at me. I need the refrigeration schedule because I'm trying to figure out how much mass flow that the BGV essentially has.
Today's episode is sponsored by the RefRushield RDP Series differential pressure monitors from Westermeyer Industries, now available for transcritical CO2 systems in addition to other common pressures and refrigerants. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace that filter? Wait too long to replace, and you could end up with a nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The RDP Series differential pressure monitors, including the new transcritical CO2 model, are available now from Westermeyer Industries. To find out more information, email sales@westermeyerin.com. That's WESTERMEYERIN.com.
If I find that out and I have the horsepower of the compressor, I could figure out the percentages of like when it would be viable to actually bring it on. Why are you shaking your head?
I just play with it till I figure it out.
We were joking about that. You were like, because they were like, what do you think Kevin does? And someone said, yeah, I think he just forcefully screws things until he actually gets it working.
Fuck you. Yes.
I didn't say that. It wasn't me. It was one of the kids.
It works out every time. But I'm serious. Like using the iPro percentage as a driving force for the compressor.
No.
I think would be great. It's going to move quick. Think about it. Especially if we're using ramp up and down times that are like 1 to 2 seconds, it should react relatively quick.
So New Andre was talking about doing something like almost like a loop sequencer, but like a digital output, like almost like you do with a subcooler. If you have one that is like it's a third, right, and then it goes to another percentage, and then it gets up to where it turns on another stage, and then the other one where it turns on the third stage, where it basically maybe breaks off the compressor or whatever. Doing something like that. We were discussing it briefly, but like I said, I got to get all the information first before we start to play with the numbers, just to see if it's viable, right? Because like right now, that compressor hasn't ran. Like the suction, because it's down one compressor right now, and the suction has actually gotten all the way up to 540 on the suction, and then it still didn't bring it on because it didn't get to the set point that the suction is. It's just like 550 or whatever to actually bring it on. But it doesn't make any sense because it doesn't even disable the BGV. So it would kick on for the way it's ran right now. It would kick on for 1 second and then shut the hell down. You know what I mean? It would enable it just to get the pressure down. And that's not what an IT compressor is designed for. It's not for, hey, I'm overburdening my medium temp suction. I should probably now bring on the IT compressor. It's supposed to be able to handle the excess flash gas when it's super, super hot out. And once again, I'm in Houston right now.
Yeah, but here's the problem. All of these are so oversized. These racks, everything's so oversized that you're never going to run into this. It's like that giant rack I started up that I dumped 2,600 pounds of gas in, or 2,400 pounds of gas in. Yeah. And I have 2 compressors that haven't run since startup.
Really?
Yeah, they're never going to run. It was 97 degrees. They're never going to run.
Yeah, so this one, the IT compressor is 35 horse.
That's insane.
I know, and I forget. I looked at the freaking iPro or the BGV like 400 times today. It's the one. It might be an CCM. Which one is the one that's all silver that has the actual like the connector that's actually connected on top of the valve? The Danfoss one. I'm running a blank on which one that is. Is it the CCMT? The one that has the little pigtail on the top, like
yes.
a sport. CCMT, yes. Right?
No, that's ETS valve.
Yeah, so it was a fairly big ETS valve, but I'm not sure which one it was. They had and then tomorrow we're replacing the iCAD, which is going to be interesting because it's the new one. That's the Bluetooth. Have you got to play with those yet?
Go
ahead.
Thinking about this, so I would think a smaller compressor would be better on the interstage if you were running like a 10 horse and just taking some of that vapor off and then still running the iPro at the same time and bleeding off whatever little bit of vapor they got too much.
See, I don't know about that because then the two algorithms would basically fight each other, right?
Yes and no. Not if they're the same algorithm.
Oh, if you're saying if you're running off the actual iPro. Yeah,
and then you're just enabling the iPro at minimum because you could run like my rack. Like I have a way to disable the iPro because I have a Danfoss driver instead of an XEV valve. I have a Danfoss driver, so I'm able to kill the DI on there. So if I need to, I can I can energize the DI and I could allow the valve to start opening some and take some off the compressor load. Because I'd rather have an undersized IT compressor than an oversized IT compressor. Because think about this. The flash tank is the most important thing. If the flash tank is shit, the whole rack is shit. So trying to control the IT with the flash tank with an oversized compressor that's hunting all over the place sounds like a terrible idea. We're just throwing any efficiency out the window at that point.
No, I agree with that. I agree. So I was talking with Bob about this when we were down in Florida. Because I was trying to I've never tried to figure it out, right? So what he was telling me, essentially, you'd have to figure out the full mass flow of the unit. And then, remember this TaxMan thing? Hold on, let me bring this up because I actually have it up in the same presentation. So using the liquid quality lines, right? So 10, 20, 30, 40 right here. You're essentially figuring out how much percentage of that mass flow is going to be vapor at X temperature, right? So if you know that your gas cooler is going to run at 85 degrees or 90 degrees when it's 90 degrees out, you could essentially figure out, okay, if it's producing this much liquid, then it's producing this much vapor. And then if it's producing this much vapor, then you could basically size the compressor, the IT compressor accordingly. You know what I mean? But then you could size it, give it for a little bit smaller of a range and let it run more often. So as long as you had a compressor that was capable of doing, let's just say even 75 degrees, because if you do 75 degrees, that's what, oh, shit, hold on. If you do 75 degrees, that's basically what this side is, I believe. Yes. So this is 75 degrees. So if you could figure out, let's see, 10, 20, 20%. So 20% vapor. So if you could figure out essentially how much energy this would be and how much energy this would be, size your compressor accordingly, and then you could get more use out of that IT compressor. Does that make sense?
Yeah, but the only problem is, I think with an IT compressor, it should be sized. If you're going to do this, you need two VFD compressors.
You think so?
Yes, you need one size for when it's hot, and you need one size for when it's like warmer.
I mean, if you picked one that would fit both detail, right?
You're never going to get one that's going to fit both details.
Maybe you will. Maybe I'll prove you wrong. Let me get my P&ID. Let me get my refrigeration schedule. Maybe
then some engineer is going to add 15% to it, and then it's fucked.
You're such an asshole.
What is there a fucking lie? Then some other guy adds his 10%. Then the compressor manufacturers, they better add another 5%.
I just like another 5%, so it's like 25% oversized. We're fine.
Yeah, by the time you know it, it's 25 to 30% oversized, and now you got a 45 horse.
It's whoever has the PE, right? Whoever tags that freaking thing.
You can get those. You can get those up in Massachusetts.
It's Maine.
It's Maine.
The participation PE.
Yeah, that's what you call the participation PE.
Oh, you need one? You need a PE? We're just giving them out. Well, it's like what happened when I moved to Texas. I got a refrigeration card. What is this for? You moved here. I was like, okay.
Stop it.
Participation PE.
God damn it.
I'm so tired.
Now we're never getting a sponsorship in Maine. Or any engineer. What
do they have? Lobster? They got lobster and maple syrup. I'm good.
I don't even like lobster.
I like lobster.
Oh my god.
Go ahead.
Like the parallel compression thing, it'd be interesting mirroring the iPro signal and playing with it, because I think that's a much better thing. I don't know. After messing with the iPro more and more, like that thing is dead nuts on for the receiver. Like I tuned out the one at my job, and it's plus or minus 2 pounds.
Really?
With very little effort.
What'd you do for a proportional?
I don't remember. I had to look
40?
at it.
40?
No,
40?
way less.
Really?
Tight. It's
really?
tight.
Okay.
But I'm running the rack off saturation. So like I'm running the rack off the fans are running off saturation. So I'm not running off droplet temp. I'm running off pressure converted to temperature, and then when it goes transcritical, it runs off fast recovery.
Makes sense.
Runs beautiful. Now the iPro and the fans aren't fighting, and everything's happy, and it sings along in harmony.
I saw that once. They did something where the saturation pressure gets to 1055. It like reverts the control set point down to minus 32 or 32 or something like that, and just runs the fans flat out.
I don't even do that. What I do is I force once I get to 85 degrees, or 80 degrees, because usually with the 10 degree TD, you're just about there, or 7 degree TD, whatever it is. At 80 degrees, I lock the ambient at 80, and I lower the TD set point from 7 or 10 or whatever it is down to 1.
Really?
So that way it has a switch over, and then it has to be below that outside air temp for 20 minutes before it comes back out.
You doing that all with the Flexi or what?
I'm doing that all with the Flexi, and then That way, I have a max TD and a max ambient, so it won't go any higher. And then I put the 1050 is my fast recovery with like 100-pound differential. So it has to go 100 pounds under the fast recovery, so that way it isn't banging in and out. It works great.
Gotcha. So I meant to ask you, so I keep seeing this more and more because everyone's, oh yeah, we just use the ambient temperature sensor. And now what I'm finding on the adiabatics anyway, they're using the post-pad sensor, which makes sense, right? Because you're either pulling the air, but you're still pulling the air off of the ambient. And so if there's no water, then it's going to be the true blue ambient. If not, and I didn't realize like it drops that temperature down. And I was actually surprised.
Well, here's the thing. So I find this a lot.
Okay. Let me finish. Go ahead.
Because Jesus Christ. Yeah, then my wife just gets furious, but the fucking kids were supposed to be watching them, so that was the puppy just absolutely just mauling the cat.
Because it's probably the same size as the cat right now, right?
Yeah, it's fucking ridiculous. Fucking. Ugh.
Anyway,
but,
no.
Go ahead.
I know, we were talking. I was talking about how amazed I was at how much temperature the post pad temperature sensor was dropping.
You got to watch, because here's the thing: that 90% of them are in the wrong spot, and the water's hitting them. So the water's hitting the sensor and making the sensor read colder than it is. So you got to find a spot, like especially the Guntners and the BACs, where they have them like mounted. Sometimes they get water spray off on them if the water flows too much. So you got to mount them in a way where they're not going to get, where the pads are up far enough where you're not going to get that water spray on them.
How far up do you go? How far? Okay, so two questions. How far up do you go in the coil, like diagonally up, and how far close to the coil do you get?
With the Guntners, I've been taking 18-inch box probe and using that, because if you drill from the side, you could usually get, it's more up towards the top, because if you go any farther down, then you're getting water droplets on it, and it's throwing it off. Now, if you live out in the middle of nowhere, like Arizona, hell yeah, dude, like it's insane how much they drop the temp.
Yeah.
I mean, they could drop it 30 degrees. But
yeah, that's why they have that's why they have the swamp coolers out there.
I seen one the other day though that somebody sent me from up in Chicago, and it was like 65 or 70% humidity. I go, that temp is not dropping 25 degrees. It's not possible. There's not enough. There's not enough. It's too humid for it to drop it that much.
So today's humidity, Houston.
The BACs do a damn good job with the amount of water they put over the pads, so they do drop it more, but also they have a higher propensity for the water to hit the sensor.
So currently it was 77% humidity. It was probably higher today because it felt like shit. But anyway, so it's 77% humidity. So the air entering was essentially on the BAC, it was showing that it was 89. And it was dropping down to about 74 or 76.
How is that possible with the relative humidity in the air already?
I think you might be right, because there's something that was wrong. But yes, I hear what you're saying. Because
you look at an enthalpy chart, like it physically can't do that, because there's already too much humidity in the air for it to absorb that and boil off. I'm sorry.
It wasn't. No, it was. I was reading, for some other reason, it came up as something else. Cloud cover is 76%. Dew point is 74. Humidity was 59. So it wasn't as extreme.
But still, even at that, I would think it would still struggle.
I don't know. I got to talk to someone else smarter, because that's one chart that I never really got into as far as the pH or the.
I understand it. I just don't spend a lot of time looking at it, because it's like one of those things that's boring.
Yeah, I know the other chart better, the pH diagram better than I do the enthalpy.
Yeah, but that's the thing. Like, everybody's, oh my God, these adiabatics do so good. Are they doing so good, or is the temp sensor getting water droplets on it, making it cold? Because if you have cold city water coming in,
see that we don't. So this water is fucked up. So the water actually comes in from the street, right? But then it fills up tanks, and the tanks are outside above ground. So they're getting beat on all day long. So like the water coming up isn't that cold at all. That's the other thing too. There's no regulator on these things, so they're all over the place.
Yeah, that's a big thing I've seen. So like I think a box probe works much better, and then I would like to see a box probe with a shield on it.
Yeah, that would make sense.
Or a box probe with PVC over it with a bunch of like slits in it. So that way the water droplets aren't hitting it. That's the only way you're going to get a true measure of how much this gas cooler is actually doing. Because in some things, adiabatics just don't cut it. Like they're not better. They're more of a hassle. We have plenty of dry gas coolers up here, and they do okay. Do the adiabatics do better? Absolutely. But what's the water usage? And are they keeping up with the cleaning and the chemicals?
There's no chemicals in those.
Yeah, but exactly. But look at the pads after a couple of years. They're destroyed.
Did you ever see someone actually put chemical on them?
No.
I did. I wish I would have I got the pictures from the cat.
Melt the pads.
Destroyed it. Destroyed the fucking pads. It looked like you just dumped a battery acid on something, on plastic, and it just destroyed it.
Yeah, I've seen what the hard water does to the pads, and it's iffy.
Yeah.
Long-term solution, I don't think it's better. Drill a couple geo wells or throw some geo wells in a pond out in the parking lot.
If the U.S. would ease up on EPA standards and stuff, I don't think it would work so much on a supermarket, but like for a larger facility, like food production facility where you'd actually collect the gray water. That's an amazing idea because it basically, you're taking the water that you're pulling out, the water and heat that you're pulling out from the freaking product anyway, and then finding a use for it rather than just dumping it down the freaking drain.
Oh, yeah. If you take that and use that to cool the secondary, especially if you're like a meat processing plant or some kind of processing plant where they're using a ton of water, like that's a no-brainer.
No, I just meant use it for the adiabatics.
Not even use it for the adiabatics, use it for post-cooling. How cold is that water? It's cold.
That's it. That's what I'm saying. So like you actually like put it into an area that you already are cooling. And then when it comes time to pump it up to the adiabatic, you got some super cold freaking water that you can pump up to that fucking adiabatic and get some real good efficiency out of it, yeah?
Or use it to subcool, then dump it up there.
Oh, that would be brilliant.
You use it to subcool the liquid line and then dump it up there.
Yeah, because you essentially would create less flash gas.
Who gives a shit if it's 90 degrees by the time it gets up there?
Agreed.
It's going to make it more dense, and it's going to make it more efficient.
I don't think you'd have that high of a temperature rise though. Like I don't think it would ever get up to 100 degrees. If you're pulling out 36 degree water and you still
but
water,
remember you're going to be moving it slow, so it's not going to be moving it a ton. Depending on how much water you're using,
it would have to be engineered really well.
15% oversized plus another 20.
Such a dick. Anything else you want to talk about, dude?
No, I think it's good.
All right. Guess we'll see you guys next time. Have fun, guys. Hey, be safe out there. It's freaking hot, man. All right? Careful. Bye, guys.